Okay, hello, assalamu alaikum. Let me just attach this microphone. Here we go. That should be a lot clearer. Welcome back to another episode of physics with types of forces. This time we have a quiz coming up on Tuesday. So we're going to review some of the questions and inshallah you guys will be a-okay. The main thing I will say today is it's very, very important that you download the worksheet. So please go to the links below in the description of the video. Download the worksheet, print it out, that's even better, and then work through it with me. Okay, make sure you put your own notes in your worksheet and use that as a guide for when you are revising. Okay, so without further ado, let's go right ahead. Actually, there's just one more ado. I'm going to do a quick shout out to the following random people. Let's see. Today, the shout out is going to Abdul Mohsen Darwish. It's going to Firas Al Atabi. It's going to Saud Al Abaid. I want to do a shout out to Abdurrahman Sheli, Fahad Al Abdali. Of course, I'm sorry, I'm always going to include Muhammad Atabi in my shout outs. Another shout out to Muhammad Al Fadli, Hamad Al Agali. Actually, thank you, Hamad, for introducing me to KDD protein. It's amazing. And a final shout out to Zaid Al Batil. Very good. And without any further ado, let's go. Types of forces. If a spring constant, here we go. If a spring constant is tripled, how will the force needed to stretch it the same distance change? Okay, so what that's saying is we've got a spring here, right? And of course the spring has a spring constant, right? And that is going to equal to force equals K multiplied by extension, which we just use as X, okay? Now some of you might be like, isn't it negative K times X instead of KX? And it really doesn't matter. That's the truth. It really doesn't matter. Just make sure if you get the force, if it's negative, it just means it's going downwards, or if it's like you're either compressing it or you're stretching it. So that's all the negative means. So it really doesn't matter. Right, so the force equals K multiplied by X. K, of course, is the spring constant. Spring constant. And that is X, and X is the extension. And sometimes you'll see it written as, sometimes you'll see the X written as delta L, which is length. Sometimes you'll see it as E, all right? So it depends, okay? So for this, in this instance, it's going to be X, but I do want you to be aware that we have also used F equals K delta L, right? Which is exactly the same. All right, so X, delta L, they're exactly the same, just means extension. So what's going to happen if the force needed to stretch the same distance, the spring is, the constant is tripled. All right, so that stays the same. That's what it's saying. X or L stays the same, and we triple this. What will happen? Well, let's put some numbers in. If you're not sure, always put some numbers in. So let's go. Force equals K multiplied by delta L, and I'm going to put 1 meter over here. Okay, so what's going to happen is if I make K 1, and that's just a number that I just came up with, okay? So the answer, the force is going to be 1, right? And so what happens if we look at the question, what will happen if the spring constant is tripled? So instead of 1 times 1 meter, so that stays the same, 1 meter, but instead of 1, it's 3 meters. Of course, you see immediately that the force triples. So that's the answer. Okay? If you triple the spring constant, you're going to triple the amount of force needed to stretch it 1 meter. So what that's saying is the higher the spring constant, the tougher the spring. All right? So it's going to be much tougher and much harder to stretch. What is the correct unit for spring constant? Okay, that's another good question. Let's go with red. Let's see. F equals K times delta L, right? So let's see. Delta L, that's meters. And force is always in newtons. So I wonder what spring constant is going to be. Well, let's put a triangle in here. Force equals K, which is spring constant, multiplied by delta L. So if that's in newtons and that's in meters, so you can tell what that's going to be. That's going to be newtons over meters. That's what that is. That's going to be newtons over meters. So right there, if you're not sure, just write the formula. You can find the units that way. I'll give you another example. Like here, for example, F equals m times A. Yeah? Well, I know that force is equal to newtons and mass is equal to kilograms. So isn't acceleration meters per second squared? Well, yes, it is, but also it can be newtons per kilogram. What? Yes, it can be. So these are just some of the ways you can find the units. I don't want to confuse you, so I'm just going to get rid of that. Okay, let's move on. A cardboard box weighing 15 newtons is on a rough floor. If the coefficient of friction is 0.3, what's the frictional force going to be? Okay, so let's see. The normal force, of course, what is going to be the formula? We always need to look at the formula. The formula is going to be force equals mu. This is called mu. Mu, you know, like the Pokemon. Anyway, mu multiplied by normal force. And normal force, so that's normal force, which is equal to mass times gravity. It's the same as weight. Okay, so like weight force acts downwards, normal force acts upwards, and so you calculate it the same way. It's mass times gravity. Now this here is the coefficient of friction, and it does not have units, right? The reason why it doesn't have units is because remember what I said. Look here, force equals mu multiplied by normal force. So this here is newtons and this here is newtons because that's a force and that's a force. So that's going to be like newtons over newtons, which obviously just means it has no units. It's a ratio. So that's all it is. It's a ratio between two surfaces. So it doesn't have units. It's just a ratio, which is why in the question it just says the coefficient of friction equals that, and it doesn't have units after it. Right, so anyway, let's go back to the question. What is the frictional force? So the force is going to be equal to coefficient of friction. Coefficient of friction multiplied by the normal force. So it's going to be, that's 15. It's already given to us because it's saying weighing 15 newtons. So the weight is the same as the normal force. Anytime you see weight, you've got the normal force. Multiplied by 0.3. So it's going to be 4.5. Okay? Right. Which pair of surfaces will likely have the lowest coefficient of friction? The lowest coefficient of friction? Okay. So the lowest coefficient of friction means it's going to be very slippery. Highest coefficient of friction means it's going to grip to each other very, very well. So lowest coefficient of friction, I can tell that's going to be ice and metal. I mean, that's going to be very, very slippery. If it said the highest coefficient of friction, I would go with rubber and tiles or rubber on road or anything with rubber really, because that grips very well. But since it's asking for the lowest is definitely like ice and metal or oil on, you know, tile or anything like that. That's going to be very slippery. Right, moving on. A spring stretches 0.08 meters when a force of 4 newtons is applied. What is the spring constant? So again, we're going to use this formula here. So F K multiplied by delta L. So that's going to be, what am I looking for? I'm looking for the spring constant, so I need K. So K is equivalent to force over delta L. Using triangles really helps. Like if you want to find K, all you have to do is cover K, and so you can tell it's force over delta L. So that's going to be 4 newtons divided by 0.08, which is approximately, or not, it's not even approximately, it's exactly 50 newtons per meter. that one. I think it's time to change color, and let's go with orange. A spring has a spring constant of 120 newtons per meter. So spring constant is obviously that's K. And how much will it stretch under 24 newtons? So that's the force, and we want delta L. So once again, we use the same formula. Delta L is going to equal the force divided by K, which is equivalent to 120 divided by 24, and that is equal to, did I do this right? Oh no, sorry, other way around. 24 divided by 120. Sometimes I mess up, right? Which is going to equal 0.24 divided by 120, so it's about 0.1, right? No, 0.2. Okay, 0.2 meters. Okay, moving on. Oops, still have one more there. Which statement about friction is correct? Time for green. Friction pushes objects forward. Friction always increases the speed. Obviously not, and it doesn't push objects forward. Friction opposes motion. Absolutely. And friction only exists on rough surfaces. Absolutely not. So friction is always there. Anytime two surfaces are rubbing against each other, whether they're smooth or not, friction is there. Now, it could be low friction, it could be high friction, but anytime the two surfaces are in touch with each other, there is friction. Friction opposes motion, absolutely. So if you're dragging something, you're pulling it, then friction is going to try and oppose that motion and make it harder for you. And then if you try and push, guess what? It's going to again oppose you and make it harder for you. So it doesn't matter whether you're pushing something or whether you're pulling something, friction is going to make it harder. So it does oppose motion. Okay, time for a sip of KDD chocolate milk protein. Amazing stuff, by the way. Tastes just like chocolate milk. I feel stronger already. Right, what does the coefficient of friction measure? Formula. Always look at the formula. Coefficient of friction, K delta L. So it's going to measure the roughness between two surfaces. That's, sorry, that's spring constant. Whoops. Coefficient of friction. F mu multiplied by normal force. But we don't really need that here. This here measures the roughness between two surfaces. Basically, like how they interact with each other. Okay, that's basically what it means. So it's just in the name, coefficient of friction, the roughness between two surfaces. Right. What else do we have over here? A 6 kilogram crate is on a surface. The normal force acting on it is what? Remember, normal force is equivalent to weight force, which is equivalent to mass times gravity. And so since we have 6 kilograms, you multiply that by 9.81, which is acceleration towards gravity, and that gives you approximately 60 newtons. So some of you might be going, well, hang on, it's 58 point whatever. Guys, go for the closest answer. Like, obviously, that can be rounded up to 60. So don't panic. Don't be putting your hand up in the quiz and be like, hey, the answer isn't here. If it's close enough, it's close enough. Okay? A spring is compressed by 0.12 meters. How are we doing for time? Okay. A spring is compressed by 0.12 meters using a force of 6 newtons. What is the value of K? Right. So once again, F K delta L. We've got that's 6 newtons. And that is 0.12 meters. Remember, this has to be in meters. Okay, always. 6 divided by 0.12, so that is 50 newtons per meter. Okay, hope that wasn't too hard. Let's go to some questions. A 5 kilogram cardboard box, and this time I'm going to go to blue. A 5 kilogram cardboard box is sitting on the floor. The coefficient of static friction, this guy here is 0.35. Whoops. Work out the minimum force needed to start moving the box. So what do I need? In order to get the force, I need mu and I need normal force. So I have the mu, that's okay. I don't have the normal force. How do I get the normal force? Remember, it's equal to mass times gravity. So this is how I write it in the quiz, okay? Step 1, I have mu equal to 0.35. I need to work out the force, and N is equivalent to mass times gravity, which is going to be 5 times 9.81, which is approximately 49 newtons. So now that I've got this, step 2 is going to be force is equivalent to mu times normal force, which is going to be 0.35 multiplied by 49, and that is going to be a lovely number. It's about 17.35 multiplied by 49, and it's approximately 17. And don't forget the units. Don't you ever forget the units. There's always people forgetting units. So yeah, that's it. Let me just work it out exactly. 5 times 9.81 times 0.35. So yeah, 17.16, 17.17. 17 is fine. Right, moving on. Red. A spring is originally, here's a spring. It is originally 0.3 meters long. And then once we hang a 0.6 kilogram bag on it, it becomes 0.36 meters long. That's once we hang the 0.6 kg bag. And so we need to work out the spring constant. Remember, spring constant is going to be what? It's going to be force K delta L. Oh, it's getting harder and harder to write on this thing. So let me try and make my handwriting a lot better. So I have the force, don't I? No, I don't have the force. I need to work out the force. Okay, so step 1. What do I have? I have the difference in length, which is delta L, which is going to be 0.36 minus 0.3, which is equivalent to 0.06 meters. So that's good. I have that. And then I can find the force, which is going to be mass times gravity because it's just hanging. So that's going to be 0.6 times 9.81, which is approximately 5.8 newtons. 0.6 times 9.81, which is 5.9 newtons. Stop it. Stop it. Just a second. We'll get there. 5.9 newtons. And so now I've got the length and the force. I can work out K, because K is equivalent to force over delta L, which is going to equal 5.9 divided by 0.06, which is approximately 98 what? What's the unit for K? The unit for K is going to be newtons per meter. Okay, very good. I hope that wasn't too hard. Let's go to number 3. So now here is where we really need to pay attention. So what we have here is a 3 kilogram wooden block is pushed with a force of 12 newtons and accelerates at 2.5 meters per second squared. Find the coefficient of kinetic friction between the wooden block and the table. So this is what we have. We have a block that is sitting on the table and it's being pushed, and it is initially being pushed with 12 newtons, but it is not accelerating at the rate that it should be accelerating because there is friction. You see, we know that force equals mass times acceleration, yeah? So if we have 12 newtons over here for the force, and we have a mass of 3 kilograms, then acceleration should be what? 4 meters per second squared. But it's not. Look at it. It's 2.5 meters per second squared. So that means there is friction. Now we need to find out what is the friction here. So this is what we need to work out. Right, so here's the thing. How much force is left over, really? Because even though we've got 12 newtons, that's not what the net force is going to be. So we have mass times acceleration. I have the mass. So step one, this is what I want you to do. I want you to go force, and that's going to be net force is going to be mass times acceleration, which is going to be 3 kilograms times 2.5, and these are just given in the question. That's 2.5, and that's 3 kilograms, and that's going to be 7.5 newtons, okay? So once I've found that, I know that, I now know how much friction there is, because before I couldn't tell. That's the friction force, and I couldn't tell how much it was. I know that it was, I put in 12, but I only got out 7.5. So that means the friction is going to be, friction is equal to 12 minus 7.5, and this is step 2, which equals 4.5 newtons. Now this makes things so much easier, because I know that friction has a formula, which is F, oh no, that is one of the worst triangles I have drawn. F is equivalent to, let's do that again. Mu multiplied by normal force. So now that I have F, which is 4.5, and I have normal force, I don't have normal force, but I know how to work it out. That's mass times gravity, which is going to equal 3 times 9.81, which is approximately 38. Oh, sorry, 29 newtons. Whoops. Got projectiles falling on me. So therefore, step 3, mu is going to equal 4.5 divided by 29 newtons. Zero 0.15. Okay, and of course no units. Okay, so step 1, remember, you got to find out what the F net is going to be, which is mass times acceleration. So we're always going to give you that. So there's the mass and there's the acceleration. Step 2, you subtract the push force from the net force to give the friction force. And once you have the friction force, it's easy sailing. Then it's just friction over normal force, and that's how you get the mu. And last but not least, we've got a 4 kilogram wooden crate, which is pushed with a force of 18 newtons. So once again, we've got 18 newtons, but we know that's not going to be the net force. The coefficient of kinetic friction between the crate and the floor is 0.25. Calculate the acceleration of the crate. Okay, so this time it's the other way around. So what we need to do is we need to find the friction force and not find the push force or the net force. So here we go. So we've got, what do we have? We've got the mu. So first of all, step 1, go to force, triangle please, force equals mu times normal, and so it's going to be force is equivalent to mu times n, and I know that's going to be 0.25 multiplied by what's going to be the normal force. Remember, that's going to be mass times gravity, so it's going to be 4 over here, see, the question tells us 4 multiplied by 9.81, which is acceleration towards gravity. So that's just 9.81 because it's a quarter times 4, so it's 1 times 9.81, so I know the force is going to be 9.81 newtons. So I found the friction force. That is the friction force, which is great because now what I need to do, step 2, let's go to orange. Step 2, what I need to do is go 18 newtons minus 9.81, and that's going to give me a nice number, 18 minus 9.81, and that's going to be 8.19 newtons. Now what is that? That is the push force. That is the net force, sorry. So it's going to be F net equals mass times, that's step 3 by the way, mass times acceleration, and I know that's going to be 8.19, and that's equivalent to 4 multiplied by the acceleration. So therefore the acceleration is going to be approximately 2.2 2.05 meters per second squared. And if somebody says, well, why not just 2? Yeah, you can. Just 2 is fine. Anyway, a little bit tricky. Just remember what you need to do. First of all, just know what force you're looking for. What is the question asking for? That's basically the style of questions we'll be looking for. Remember your steps. You'll be fine. Just practice questions like these. You'll be fine. Take care.